Hi, the system we are about to present to you is currently installed here in Gnazim offices in Jerusalem. It consists of a large touchscreen and behind it a computer and an amazing program, transparent to the user. The main purpose of the system is to help researchers find, in the great space of Genizah fragments in the world, close to 500,000 digital pictures, a number of fragments that are potential joints or at least written by the same scribe. This system is part of the Friedberg Genizah Project, whose general purpose is to computerize the entire Cairo Genizah and make it accessible to the public. The program that we will now demonstrate was developed by Gnazim researchers and staff, Professor Yaakov Shweka, Dr. Roni Shweka, and Adiel Ben Shalom, in cooperation with researchers from the Faculty of Computer Science in Tel Aviv University, Professor Lior Wolf and Professor Nachum Darshovitz. It is based on the latest technology used to compare two fragments and became possible after running through and comparing each fragment to each other fragment in the entire collection for a period of 2 months using very large resources of computing power. The system is open to users of our website and is accessible by the username and password of the user. Entering the software by username, there are 3 options for importing images. Select by collection function, where we have all the collections. By entering a shelf mark, or by FGP number, a number given by the website to each image in order to make it easier to work with. The joint software finds potential joints for a specific fragment. Okay. This is the fragment we are working on. We can see the details of the fragment, computer data, and if the website already has joins found for this specific fragment. We see here that there is one join found. We will use it later. Back to the image, we have an option to zoom in and zoom out on the image. Here you can see the shelf mark, Cambridge University, and the FGP number. The software shows 100 options in a descending order. The user can also mark the fragment that seems like it's a joint, or that it's not a joint, or it needs more further investigation, or the handwriting looks as the same scribe. Let's choose that it's not a join and go back to the screen. Another selection available is the checkbox. By clicking on the checkbox, we choose the images we want to import to the puzzle software. Now we'll go to the jigsaw puzzle software. Before us we see all the images we imported from the other software. This is the image we're working with. You can change the size of the image, rotate it, and calibrate the images so their size is matching the original proportion between them. Once we calibrate it, we lock the image. And now we can check if it matches one by one. Let's see the first one. The first option doesn't look similar, as you can see. So we will erase this image off the screen. Okay, let's go to the second image. Unlock it, maybe make it slightly larger, and calibrate the size of the images. Again, this does not look like a join, so we will erase this one as well. Now we will look at the last image. Again, we will change the size slightly, calibrate the images. Now, this looks like it doesn't match, but if we flip this image to the other side by the flip function, you can see that we have a join. We have the flip all function, which flips the whole thing to the other side. And we can be sure that this is a join. We will import a third fragment that is already on the website. Again, we will change the size and calibrate the size of the images. Oh, 1 second. Again, we will change the size and calibrate the size of the images. Okay. And here you can see a join from the Talmud Bavli. Once the join is found, we can save the join for further investigation under the username, or save and upload to the website, where the join and its image is visible to all the users with the researcher's name. We hope you'll have a pleasant experience and find this software useful.